In today's video, you are going to discover how you should extract data in Airflow so you can stop juggling between multiple operators or wasting time looking for the one you need. Let's dive in. This is the data pipeline we will build together. It has two tasks, extract and check. Extract data from a S3 bucket and loads it into BigQuery. And for that, we will use a special new tool that you will discover later in this video. If you want to do exactly what I'm going to show you on your computer, you just need to click on the link below and you will land on this page with everything you need, the prerequisites as well as the code. That being said, for the prerequisites, you need to have Docker installed as well as the Astro CLI. The Astro CLI is an open source and free command line interface to create, run and manage Airflow projects locally. It's truly the easiest and fastest way to run Airflow in local. To install it, you go to the following link and then Astro CLI, install the CLI, pick your operating system and follow the instructions. It's pretty straightforward, so you should not have any issues. Next, make sure that you have an AWS account as we need to use AWS S3 for this project. Also, you need to have access to a Google Cloud account in order to use BigQuery. Once you have all of that, we are ready to move forward. First step, let's create a new directory for the Airflow project. So let's say YouTube tutorial, then go into that directory and open your code editor from here. I'm gonna use Visual Studio Code, but feel free to use the code editor you prefer. Once you are in your code editor, open a terminal, and then let's run the following command, astro dev init, in order to initialize the Airflow project. And as you can see on the left, I have some new files and folders that have been automatically generated for me. Again, if you want to learn more about the Astro CLI, take a look at the documentation. So now we have this fully functional project. We can create a new data pipeline that we will call el.py. Let's keep it empty for now. Next, we need to create an AWS S3 bucket. Remember that the task extracts data from an S3 bucket. So we need to create this S3 bucket, then upload the dataset in it, and also create an IAM user from AWS so that the data pipeline can access this S3 bucket. So let's do this. In your AWS console, search for S3, then pick the service and create a new bucket with a unique name. So in my case, it's gonna be m-youtube-el. Then let's create this bucket. And once you have your bucket, go in it and upload a new file. This new file is the dataset that you can find in the Notion page right here. So make sure that you download this zip file, unzip it, and then you have access to the dataset. Retail transaction dataset has just a few columns corresponding to retail transactions, so it doesn't really matter. Here's just for the example. So once you have the retail transaction dataset.csv here, you can move forward and click upload. And now the file has been successfully uploaded in your S3 bucket. Perfect. The next step is to create an IAM user that we will use to access the S3 bucket from our data pipeline. So go to IAM, then users, create user, then give a username youtube-el. Next, we want to attach a policy directly and search for S3. And then let's give S3 full access. Then next, create user. Click on the user you've just created. Go to security credentials. And under access keys, create access key. Then select third-party service. Next, create access key. And now make sure that you download the access key by clicking on this button. And click on done. Okay, at this point you have successfully created the new user to access the S3 bucket from the data pipeline, and you have successfully uploaded the file in the S3 bucket. The next step is to configure Google BigQuery. On your Google Cloud console, select a project, then create a new project. Let's call it youtube-el, then create, and select the project that you've just created. Go to APIs and Services, click on BigQuery API, make sure that it is enabled, as you can see here, and create credentials. select the BigQuery API, then application data, next. Define a service account name, so let's say YouTube-el-service. Create and continue. For the permissions, select the role owner, continue, then done. And finally, go back to your service accounts by going to IAM and admin, then service accounts. Click on the service account. Then go to keys, add key, create a new key, JSON, and click on create. And that will download a file corresponding to your private key so that you can access BigQuery from your data pipeline. All right, the last step is to go to BigQuery and then create a new dataset. So for that, you expand this, and here you click on the dots, create dataset, and let's call this dataset retail. Then you can keep multi-region, create dataset, and a dataset is like a schema. So you can see now that you have retail, but nothing in it. All right, so everything's set up. Now it's time to move on the Airflow part. First, make sure that you have in the include directory the Google BigQuery JSON key that you have downloaded earlier. Then open the file EL and let's create the data pipeline. So for that, we will use the TaskFlow API. If you don't know what the TaskFlow API is, it's a faster and easier way to write and read your DAGs. So let's do that. Type from Airflow, decorators, import DAG and task, then datetime import datetime for the start date, and use the DAG decorator where we can specify some parameters such as the start date with datetime and let's say 2024. Then the schedule is daily. We want to run this pipeline every day at midnight. We can say catch up to false. We don't want to catch up any non-triggered past DAG runs. Then for the tags, we can add EL, S3, and BigQuery. Tags are very useful to filter your DAGs or categorize them on the user interface. Then we can specify a new parameter starting from Airflow 2.9, which is max consecutive failed DAG runs equals to 5, which means if this data pipeline fails 5 times in a row, then it will be automatically stopped by Airflow. Then last but not least, we can use doc md equals to doc, so that if you want to add some documentation to your pipeline, you can just do that by adding some comment here. Okay, so now we have set up the DAG object. Let's create the pipeline. So EL, this is the unique identifier of the pipe. And here we're gonna create the tasks and we call EL at the end. To create the extract task in order to transfer data between S3 into BigQuery, we will use PyAirbyte. If you don't know what PyAirbyte is, it's a free open source library that uses Airbyte connectors in order to transfer data between multiple sources into different destinations so that you don't have to reinvent the wheel each time you want to transfer data between a source and a destination, and you don't have to maintain like custom scripts and everything. Again, it's free, open source. This is the documentation. Feel free to take a look at it, but that's what we will use in this project. And honestly, that's what I use daily because I don't have to look for specific operators and find out which one to use to transfer data from one source to a specific destination. It is still a beta version, so I'm pretty sure that it's going to be improved much more later on, but for now, it works and it's pretty great. So that being said, in order to use PyAirbyte with Airflow, we need to create a virtual environment because PyAirbyte brings some dependencies and we don't want to end up with conflicts because of the pre-installed dependencies that come with Airflow. So let's go back to the code editor, open the Dockerfile, and then you have to create 2 Python virtual environments. The first one is for the source that you will use, in this case, source S3, as we want to extract data from the AWS S3 bucket, and the second one, which is for PyAirbyte. So 2 virtual environments, one for the source and one for PyAirbyte. Actually, the first one is not mandatory. However, if you don't create a virtual environment for the source, that source will be downloaded each time the task runs. And so you will waste a little bit of time. So that's why it's better to have the source pre-installed. So now you have that, save the file, and you can go back to your data pipeline. Here, to create the extract task, we use the ExternalPythonOperator. The ExternalPythonOperator is a special operator that allows you to pass a Python virtual environment. So in this case, the one that we've created, PyAirbyte-venv, as specified in the Dockerfile, right here. And that allows you to run some tasks in a virtual environment so you don't have any dependency conflicts. Very useful. So now we have this with PyAirbyte installed in this Python virtual environment. We define the name of the task, which is extract, and we can import some PyAirbyte dependencies. For example, here we import Airbyte, which is AB, as well as the BigQuery cache. What is a cache? Well, if you take a look at the documentation of PyAirbyte and scroll down a little bit, you can see the architecture. And basically, PyAirbyte is composed of 3 components. The first one is the source, so from which you want to extract the data. Then the cache, where you want to store the data. So you can think of a cache as the destination, and you have the result, the object holding the records. In terms of cache, you have multiple caches. You can take a look at that in the documentation again. Basically, you have DuckDB, which is the one by default, Postgres, Snowflake, and BigQuery. I'm sure that others will come, but for now, that's the caches, destinations that are available with PyAirbyte. Back to the code. The next step is to instantiate getSource. getSource gets the Airbyte connector so that you can extract data from a specific source. So as you can see here, we create a source, then we call getSource with the source we want, in this case S3, and then we need to pass some configuration settings. To find those settings, you go back to the documentation, and then if you scroll down and look for the different connectors you have, and more specifically S3, you can see here the list of available settings that you can define. 2 are required. The first one, the list of streams, and the second one, the bucket. So let's define some settings. The first one is the bucket name, then the AWS region name, where the data is, as well as the streams, basically the data to extract, in this case, the CSV file. And this setting expects a list of streams. In our case, we only have one stream, so let's create one with the name transaction, and the file type is CSV, as it is a CSV file. There are other options that are useful. For example, under the streams, you have globs. If you want to specify which files you want to extract, this is the way to do it. And then we want to specify the credentials. So how do we connect the source to the AWS bucket? And for that, we have created an IAM user. So here we need to specify the AWS access key ID as well as the AWS secret access key. And as you can see, AB uses getSecret, which is a method that pulls the credentials from the environment variables AWS access key ID and AWS secret access key. So let's create those environment variables. For that, you open the following file, and here you add your access key ID as well as the secret access key. Again, you can find that in the CSV file that you've downloaded earlier when you've created the user. Another environment variable that we can add right now is this one to test the connections that we create in Airflow. We will see that later. Okay, so save the file and let's go back to the DAG. So now we have the credentials and the configuration settings for the source. The last step is to specify install if missing to false. So the idea here is to say, hey, don't install the source S3 as we already have it installed in the Python virtual environment. So we save time. Remember, if you open the Dockerfile, we have this Python virtual environment that contains the source S3 so that we don't have to install it each time the task runs. And that's exactly what we are doing here. By specifying install if missing to false, we don't install this source each time the task runs. Okay, so we have successfully configured the source. The next step is to indicate which stream you want to use. And in this case, as we only have one stream, which is transaction, well, we can call the method select all streams. But if you had different streams for different files, then you will be able to pick which one you want to transfer from S3 to BigQuery. Okay, next, in order to transfer the data from the source into BigQuery, we call the method read from the source. And this method expects a cache, a destination. And in this case, we will use the BigQuery cache. The BigQuery cache expects some parameters as well. The first one is the project name that you can find in Google BigQuery. So here you have your project name right there. And then you need to specify the dataset name, retail, as we've created it earlier. Then the credentials path. And as you can see here, we use the following path with elbigquery.json. So let's rename the file with this one. And that's it. Last but not least, you can print the first record that will be transferred. Okay, so that's it for the extract task. To sum up, to transfer data from a source into a destination using PyAirbyte, first you need to create 2 Python virtual environments, one for PyAirbyte and one for the source. Again, it is optional, but I recommend you to do that with Airflow. Then you need to use the Python external operator with the PyAirbyte virtual environment. Then you need to define and configure the source with ab.getSource, and you select your stream. After that, you define and configure the cache, the destination, in our case BigQuery, but there are others like DuckDB or Postgres. And finally, you transfer the data by calling the method read with your cache. So that's how you transfer data between multiple source and destinations using PyAirbyte and Airflow. Now let's implement the last task, which is check, to make sure that the data has been successfully transferred into BigQuery. At the top of the DAG file, make the following import from Airflow providers, Google, Cloud, hooks, BigQuery, and you import the BigQuery hook. Then, after the extract task, create a new task with the name check. Instantiate the BigQuery hook with some parameters. The first one is the connection ID that we will create later in Airflow. Then use legacy SQL, as we don't want to use legacy SQL, but instead standard SQL. And the location, which is US, so where the dataset retail is. Next, we create the SQL request that we want to run in BigQuery to make sure that the data is here. And again, dialect standard indicates that we don't want to use legacy SQL, but standard SQL instead. And finally, we can just print the number of rows in the table. So that's it for this task, pretty simple and straightforward. The last thing we need to do in this DAG file is to define the dependencies, so we execute extract first and then check. As you can see, we use chain, so we need to import this method that makes it easier to define dependencies in Airflow. So from Airflow.models base operator import chain, save the file, and you have successfully created the data pipeline. The very last step is to install some operating system dependencies. For that, open packages.txt and add the following dependencies. Those are required by PyAirbyte. Save the file, and now in the terminal, type astro dev start in order to start Airflow with the Astro CLI. Let's wait a little bit. Okay, Airflow is running. You land on the user interface by default, and you can type admin to access the DAX view. And here you have your data pipeline, EL. So click on it and take a look at the graph. So you have the 2 tasks, extract and check. Perfect. The last step is to go to admin, then connections, and create the BigQuery connection. So add a new record. Here, call it BigQuery as defined in the check task. Search for the connection type BigQuery. Then you need to specify the project ID. So you can use the same one defined here. Like that. And the key file path is the following one. So again, just copy this and paste it here. And that's it. You can test the connection by clicking on this button and verify that it works. Perfect. Click Save. Go back to DAGs. Click on the DAG. And before running it, let's verify that we don't have anything in the retail dataset. So let me refresh the page. Okay, so nothing in retail. And now let's run the pipeline by turning on the toggle right here. So let's refresh the page. Perfect. One DAG run is running. We can take a look at the logs and see what's going on. So let's wait a little bit. And the pipeline has been successfully executed. As you can see in the logs for extract, you have the number of records that have been transferred from S3 into BigQuery. And in fact, if we take a look at the check task, we have the number of rows, which is the following one. And if you take a look at BigQuery, then refresh the page, you can see under retail, a new table transaction that corresponds to the data that we have in the CSV file. So congratulations, because at this point you have successfully created a pipeline that transfers data from a S3 bucket into BigQuery using PyAirbyte. But more importantly, now you don't have to use any other operators to transfer data efficiently between one source and a destination. Just use PyAirbyte with the external Python operator, and that's it. So I hope you enjoyed that video. Let me know what you think about that in the comments below, and I see you for our next video.